widescreen monitor, I suspect it has exactly the same number of pixels as the more expensive ones, like down here, even for the 24-inch. So we are still looking at 1920 by 1080 or so, as the resolution of the screen.
It's just stretched out.
Exactly, the pixels are bigger. So it depends. If you have really good eyes, like I prefer a smaller monitor at a really high resolution because I got relatively good eyes. My lenses, are progressive, which means I can no longer control the focus, but as long as it is corrected, my vision is actually better than 2020. So I can deal with tiny little fonts and little details on the screen without any problems, and I prefer a smaller screen so I don't have to pan my head. when you have a progressive lens, you will understand why you don't want to pan your head. Because with a progressive lens, not the entire area of my lens, is actually usable. There's a tunnel, they call it a tunnel, that I can use, for focusing. So if I want to see something at the corner of my eye, I actually have to turn my head to make it in focus. So that's why a bigger screen is not really better for me. I actually like a smaller screen, so I don't have to turn my head as much. That's a sign-in sheet for today. Now, in this case, because you're purchasing a desktop computer that does not have a, included monitor, which is good, because you can basically say no monitor, and that way you can buy your own monitor. From Amazon.com, go to Costco, go to some other places, and get your deal. Or use your old one if you have one that is really nice already. So I'm not going to buy any one of these. Graphics cards, okay, for gaming. Since I'm not a gamer, I will leave it up to the gamers to comment on these graphics cards. Is it worth $180 for the Radeon XD 5770 1 gig GDDR5 graphics card?
Depends on what you play.
Depends on what you play, okay? So not all games can utilize a faster graphics card. That's basically what you're...
Well, yeah, but I mean, some to a point where it wouldn't make a difference.
Yeah.
You
Okay.
know what I'm saying? Like the frame rate it won't increase enough for it to make a difference in the particular game you're playing. I mean, a lot of games now, the faster the better, but...
Like you can get a pretty decent one right now for like $50.
So the $50 option, one of these two, is reasonable?
Yeah.
Okay. Now remember, when you look at the frame rate, when you're comparing a frame rate of 15 to 30, that's a huge jump. Okay, that 50% is a huge jump because your eyes can pick up, maybe up to 20 up to maybe 30 frames per second. In other words, anything that's slower than 30 frames per second, your eyes will see it as jagged motion. Okay, you can actually tell, that it is kind of jagged. But anything faster than 30 frames or maybe 60 frames per second, you cannot tell anymore. Okay, can anyone say for sure, you cannot tell like from 60 to 120 frames per second? The difference is so minor that most people cannot tell. Is that true?
That's, yeah. 60 is where they say.
It's the optimal, right?
Yeah.
Yeah, any more than 60, you cannot. It's not worth the increment of price. Yep. Okay. It has to do with the sampling theory, because your eyes really only have a sampling rate of 30 frames per second, but you need twice that in order for something to look really smooth. So you need 60 frames per second so that your eyes cannot see any flickering anymore. Now, if you were a fly, then you will need a much higher frame rate because flies can see things way different from what we do. The fluorescent lights which we see, like even the screen here, we see it as kind of constant and static, especially when there's no motion. If a fly is flying by, the fly will actually see all the flickering, all the pixels turning on and turning off, it will see all the refreshes. In fact, let's check out how much flies can see. Fly, eyes, refresh, flicker. Okay, I think that will find something. Persistence of vision, that's the technical term to describe, after a image is gone, how long does the image stay on your retina or stay in your brain? Part of that is your brain and part of that is your retina. So there's a whole bunch of research. We'll just go find out. Computer monitors, cartoon animation, persistence of vision display. See also. We'll just try to skip to the fly. Oh, it doesn't talk about flies. I know that flies have a really high frame rate. Can anyone imagine why flies have a much higher frame rate than we do?
Compound eyes?
Compound eye is basically describing they have individual eyes, and each one can only see basically one pixel, but they have many eyes. But it's not because of that. It's because of, well, if you believe in evolution, it is because of evolution. Because what happens? Yeah.
I was just going to say that they have more sensors, but we can also see faster pixels, especially when we're stressed. They've done research pushing people bungee jumping for the first time, and then they have a digital clock that has random numbers flashing, and then they can actually tell what the numbers are, because normally they're imperceptible to what the pattern is.
Wow.
But they've actually been doing some research.
Interesting. That is, but I don't think we can even approach the frame rate of the eyes of a fly. It's because flies have predators that are also very fast. So they got to be able to see what's coming, so to avoid it. Have you guys tried to hit a fly with just newspaper and whatnot?
Yeah.
Sometimes you can do it, and sometimes it's pretty hard.
You've got to hit not where they are, but just in front of them.
Where you think it's going to be? But flies can fly backwards too.
Yeah, they usually
They can launch and fly backwards.
When they take off backwards and go up. And I heard if you try to catch them or hit them with something, I heard they can actually sense up to 5 inches away from them.
Wow. And they can react very quickly too. Yep. So anyway, fortunately we are not flies, so we can settle for anything with a frame rate of about 60 frames per second is good for us. It's going to be very annoying to a fly, but to us it's good. To a fly, it's like someone turned off the light in the room, wait a second, turn it back on again, wait for a second, turn it back off again. So it's very annoying to the fly. All right. So in this case, this is a lesser graphics card, and many people in the class recommend the $50 option. Now, any preference of the chipset, Radeon or NVIDIA?
I've used Radeons. I haven't had any experience with NVIDIA.
Okay.
Video graphics cards are pretty good.
Yeah.
Sorry?
Video graphics cards.
NVIDIA's are pretty good. How about in terms of support and drivers and stuff like that? There's one company.
More with Radeon.
Yeah, I've had good luck.
Because Radeon is integrated in a lot of
Motherboards, okay.
like when you buy them off the shelf.
Okay.
Computers, so for the most part, it's Radeon. So I think more systems.
Very good.
I've had better luck with NVIDIA personally.
Okay.
than Radeon, but
So it's not a lopsided win one way or
They
another.
both have really good drivers.
Okay. If you use Linux, then it does make a difference, because in Linux, NVIDIA does not release their driver in open source, so it's always a hassle to have to recompile and install the NVIDIA driver. It is available, it is one more step, so it's kind of a hassle to do it. But I guess in the case of Windows, especially when it is pre-installed, it should not be an issue at all. Okay, so we can pick either one of these. Now, why do we need 1 gig of RAM on the graphics card? Go ahead.
Doesn't distribute that RAM just for processing the graphics? What's happening?
Well, the RAM on the graphics card is used to store the pixels. But if you do the calculations, we don't need a gigabyte to store all the pixels on the screen. Okay, let's do some calculations here, just so that we know why we need 1 gig or whatever amount of memory. So let's say we're dealing with a full HD widescreen monitor. So you have 1020 wide times, let's say you have a really super duper one with 1200 pixels vertically. And each pixel has RGB components, and let's just say that let's say each pixel needs 32 bits. Okay, so basically you have to divide 32 by 4 to get a number of bytes. This is basically how many bytes you need to represent all the pixels on a full HD widescreen monitor. So we have 18,000 pixels here, or 18 million, excuse me, about 20 million pixels. 1 giga is about 50 times this amount. So the question is, well, even if you want to set up a triple monitor setup, you only need 60 megapixels or 60 megabytes. Why do we have 1 gigabyte on the graphics card?
So you can have different screens already preloaded, so you don't have to have that wait time.
Exactly. It's also used to store textures. Okay, if you're rendering anything, with your graphics card, the texture of whatever object it is drawing is actually stored on the graphics card as well. So that's why you have to have a lot of memory, because basically whenever possible, the graphics card will try to render images ahead of time, so that way it can keep up with the frame rate. And also it is also used for texturing and many other things that the graphics card needs to do. So does everybody agree that 1 gig is about right for most games?
You don't necessarily need it,
But it's not underperforming. 1 gig is not too little. Okay. All right. Cool. That's included too. This one is actually included already.
It changed when you clicked on it. If you look at the one above, it says.
Oh, okay. I see. Okay. So this is the one that was included, and for this one we have to add $50, which is not too much. So that $50 can be money well spent if you play a lot of games. So continue. Okay, this is about the hard drive. So once again, you have to kind of assess what you're doing in order to find the right size of the hard drive. Hard drives, like memory, can be upgraded later on. Okay, so basically, you don't have to get the right size the first time. You can always add more hard drive space later on. And this is expensive. If you look at a 1 terabyte option, you have to add $150 on top of what you're already paying for the half terabyte hard drive. I saw on the ad one other day you can get a 2 terabyte hard drive with rebate for about $100. So this is quite expensive. It also depends on what type of hard drive you're getting. Apparently, different manufacturers have different product quality. Who makes the best hard drive today? Maxwell? Maxwell?
Maxter.
Okay, Maxter. They keep changing. Okay, there was one time where Western Digital (WD) made the best hard drives. Sorry.
That was Western Digital was known as the best hard drive for a while ago, or best brand.
Yeah, but that was a while ago. And then Seagate, came back, with really good hard drives. And then after that, Maxter is good now. So it depends on the brand, and it also depends on which time frame we are talking about. There was one time Hitachi was cooperating with, or they were working with IBM to come up with the Death Star hard drives. Those are commonly known as Death Star hard drives because they die in a very short amount of time. I personally have bad experiences with Western Digital hard drives, especially the ones that are designated for servers. The first reincarnation of the Moodle server used, Western Digital hard drives, and I already had a RAID setup, a redundant array of inexpensive drive, setup, 3 drives with 1 spare. There was one time that 2 drives died almost, at the same time. So I was down to only 2 drives out of 4, which is the bare minimum to get the array working. Any more failed drives and I'm toast, man. I have only used commercial grade, Seagate drives, and I don't power down my system at all, and I have yet to have any problem.